On July 9, 2026, the internet reached a point of no return. For the first time since the creation of the web, human users are the minority. Cloudflare data confirms 57.5% of HTML web traffic is now initiated by automated machines. This isolates AI from traditional network noise, like scrapers or DDoS attacks. Purely AI-driven requests now account for 26.7%. Most of that traffic consists of extraction crawlers used for model training, alongside a growing share of AI search bots retrieving real-time data to answer user queries. These metrics track the structural HTML and text requests that form the web's backbone, excluding the passive data loads from video streaming and gaming. The majority of individual requests across the open web are now being initiated by software, not people. This shift was documented by Cloudflare CEO Matthew Prince, whose network infrastructure processes roughly 20% of the world's web traffic. While human activity remains static, AI agent traffic has grown by 7,851% in a single year. Breaking this down, we identify the specific actors: Googlebot, OpenAI's GPT-bot, and Anthropic's Claude-bot represent the largest shares of this automated load. These aren't simple scripts. They are autonomous agents capable of planning and executing multi-step tasks across different websites to reach a specific goal. These agents operate under a different set of constraints than humans, capable of making requests at a frequency that challenges the existing rules of network capacity. Until recently, using AI was a synchronous process. You opened a chat interface, sent a prompt, and the AI responded while you kept the browser tab open. That changed with the launch of Anthropic's Claude Cowork, which introduced a cloud-native architecture that decouples the task from the user's physical device. In this new model, the user hands off a task to a cloud agent and goes offline. The agent runs independently in the background. It connects directly to database, spreadsheet, and email APIs to extract data without active human supervision. If the workflow requires high-level authorization, the agent pauses and sends a mobile notification, requiring the user to tap Approve before it continues its automated task. With the Codex platform now reaching 5 million weekly active users, this capability has moved beyond software engineering and into the daily routines of non-technical office workers. Removing the requirement for constant human attention allows these intelligent agents to execute thousands of concurrent tasks simultaneously across the global network. To understand why the network load is changing, we have to look at the behavioral asymmetry between a human and an agent. A person researching a report might load 5 or 10 pages in an hour. When an agentic architecture receives that same task, it doesn't navigate linearly. A central meta-agent receives the command and immediately fractures the task, spawning dozens of subagents. These subagents concurrently ping hundreds of servers to scrape data. A single human instruction is converted into thousands of machine-to-machine requests. This architecture allows a single user to generate a volume of traffic that previously required a large-scale botnet. This multiplier effect, parallel sub-agents running in the cloud, is the primary driver of the 57.5% traffic shift. This shift is being incentivized by the pricing models of major AI providers, like OpenAI's GPT-5.6 Sol, released in July 2026. OpenAI designed this model specifically to manage the sub-agent workloads that generate this high traffic volume. Running these tasks is expensive. High demand for HBM memory bandwidth has led OpenAI to charge a significant premium for its fastest model performance. To manage these costs, they use a system called prompt caching, which stores the AI's current context in memory for 30 minutes. It costs 25% more to write data into the cache, but reading from that existing cache comes at a 90% discount, as long as it's used within a 30-minute window. This pricing model encourages developers to build agents that run continuously. By keeping the agent looping in the background, they can reuse the cache data before it expires, significantly reducing their operating costs. The economics of the industry are now optimized for continuous machine traffic. For 20 years, the web relied on a trade-off. Search engines were allowed to crawl a site's content in exchange for sending human visitors back to that site. AI agents interact with the web differently. They extract the raw text and then terminate the connection instantly, bypassing the rendering of the page and the delivery of advertisements. This change is measured by a metric known as the crawl-to-refer ratio, the number of times a site is scraped versus the number of human clicks it receives. In traditional search, Google crawls about 5 pages for every 1 human visitor it sends back. Look at the ratio for Anthropic's Claudebot. It crawls over 11,000 pages for every single human referral it provides. Over half of all agent activity is now used purely for base model training, meaning these requests offer no possibility of a return click for the content creator. The ad-supported model cannot survive when the majority of users consume raw data without ever viewing a visual page. Publishers are responding. More than 1 million websites have already configured their infrastructure to block AI crawlers entirely. However, publishers face a difficult choice. Because companies like Google often bundle their AI training bots with their traditional search crawlers, blocking the AI often means losing all visibility in search results. Static blocks are unlikely to scale. Agent traffic is projected to grow to 1,000 times the volume of human traffic within 5 years. This is leading to a change in how information is served. The public, human-readable HTML cage is being replaced by strictly gated machine-to-machine API endpoints. In this new environment, publishers are turning to cryptographic microtransactions, where AI providers are automatically billed for every piece of data their agents retrieve. The ad-supported web is being superseded by a transactional grid designed for machines to exchange data through secure, automated channels.